Haven't.
Same old, same old.
Same old,
I mean,
same old.
applying.
Are you on campus right now?
I
Are you in
am.
the
Yes, sir.
are you in the alumni
In
room?
the alumni room. Yeah, now that I'm an alumni,
You look
got
different.
full
You,
reign
you
over
must
this
have gotten a
place.
haircut or something.
I must have. It must be the hair.
It must be the hair.
Are you joking? Like, is he serious? Yeah, but same old, same old. I got a few assessments to do. I've an interview on Tuesday, so it's going.
Cool. Yeah.
Oh, I'm the host.
It's slow, but it's
Yeah, but gotta
gotta
trust the
do it.
process, I guess.
It's crazy, like to think that like this new cohort is like already like almost halfway done.
Yeah, I think they're on their second project.
And we're just like, wait, job, please? What's going on?
Yeah.
Well, good morning, guys. Thank you for joining us today. I don't have much to say, so I'm going to give the floor to Charles, but there is one role that, well, not role, but an opportunity with Capital One Bank. So if you're interested, I had sent out the email yesterday evening. Please let me know if there's a particular role that you're interested in so that we can have it reviewed by our hiring partner. And she will be the one to give you the referral link afterwards. So if you do see it, Hugh, I did see that you sent me your interest in there, and I'm going to follow up with her very shortly. Please let me know if you're interested in them because they're hiring for quite a few roles and she'll be able to do referrals. I believe she worked with the company before. So yeah, that's the only announcement that I have. If you guys need me, what you guys need to do. Otherwise, I'm going to pass the floor over to Charles. Thank you, Charles, for doing
Courtney,
this. Yes.
I just had a question about the Capital One position, actually. I was looking into it, and it looks like there's a bunch of them. Like there's like data scientist for X, data scientist for Y, data scientist, blah, blah, blah.
Right.
So like, what's the protocol on like applying for multiple of those positions? Or do you know anything about that?
I don't want you guys to apply to them yet because if you were to apply to them, then you wouldn't be able to use the referral.
Okay, so we should reach out to you.
Right. So let me know what roles you're interested in. You would send me the job link and the title of the role, and then I would forward it to our hiring partner who will go over your resume and the job descriptions to see if it would be a fit, if she's comfortable with giving you the referral, and then she will reach out to you. She may even give some pointers on some updates that she may recommend for your resume as well. So yeah, that's all that you need to do. Just don't apply yet because I don't with them, it would just be best to get the referral. You can't put the referral in after you apply. So just let me know which roles. It could be a couple. I had somebody send me like 2 roles that they were interested in, and I plan on forwarding that over as well. So just let me know, and then I'll figure it out and follow up.
Okay, sounds good. Thanks a lot.
No problem. All right, Charles, the floor is yours. Thank you guys for joining us today. I'll be in the background, so if you guys need me, let me know.
Gotcha. Do you mind just dropping the link for the Dropbox? There it is. Thank you. All right. Hello, everyone. If you don't know me, my name is Charles Phillips. I'm a recent graduate from the NYC DSA, just this last September cohort. And Vivian sort of asked me to share sort of like the problems I've been trying to do preparing for interviews. So what we have for today is if you follow the link in the chat, if you download the attached zip file that has the Jupyter notebook we'll be working out of today. It's got a bunch of different problems that we'll be going through and just sharing some of the resources I've been using to try to prepare for the technical side of the interviews. So I'll give everyone just a minute to sort of download the notebook and open up your environment. All right, is everyone set, or we need another minute?
All
right,
I'm almost there.
All right, another minute.
Just closing all my stuff. Okay, I'm good.
All right. Oh wait, I should share my screen, right? Yeah, probably. All right, so on top of the notebook, the first thing we'll be doing today is we'll do some SQL practice, and a resource that actually I was pointing to from someone else in my cohort is this website called Scratch. So if we all click on the first link for problem 1. Also, just introduce you guys to the environment that they supply. I will delete my answer. I don't give away anything. So this is Scratch. Hold on. If you go to their homepage, they got a bunch of coding questions you can use. You can go through. They're sort of this whole website is tailored to SQL practice. So down here, all the questions, they're labeled from what companies they were allegedly asked by, their difficulty level, and some other information. Up here, you can filter by company if you're so inclined. You can also filter by what language you'd like to use. And there's some advanced filters. You can play around with like sort of how to filter out questions. But if I just go back to this link for problem 1, this is what the sort of environment looks like for a problem. Is you're given this box where you'll enter your SQL query. You do whatever. Down here is the problem description. Over here are is the data you'll be using to give you the tables. And if you want to take a gander at the table, you just click on preview, and the preview will pop out over here. So it's pretty straightforward. Are there any questions about the environment or how to do something in the environment? All right, if not, I'm just going to sort of treat this 2-hour session sort of like the homework reviews. We'll break out for 10 or 15 or 20 minutes, something to sort of work on the problems individually, and then come back together and we'll discuss solutions or any hardships we encountered while trying to solve the problem. So for this first one, we want to write a query, calculates the difference between the highest salaries found in the marketing and engineering department. And we want to output just the absolute difference in salaries. So we have an employees database, we have a department database, and from that we want to find the difference of the average of the engineering salaries and from the average of the marketing salaries. Yeah. So if there's not any questions, I'll give everyone let's say 10 minutes. We'll reconvene at 10:20 to sort of talk about our solutions. Courtney, is there a way to do like breakout rooms or something?
Did I make you host?
Oh, I think you did, yeah.
Yeah, I think you should be able to do it from your end. I'm not exactly sure, but there should be like a breakout option.
Oh, yeah, okay.
See it?
Yes, breakout rooms.
Create. Yeah, I can't see it on my end because I don't have the hosting.
Oh, yeah. All right, guys, I made some great breakout rooms. So if you want to talk to someone about the problem, sort of bounce back ideas, bam. All right, welcome back, everyone. So is that ample time for anyone, or do we want to wait another few minutes for anyone? All right, I'll take that as we're set to go. All right, so does anyone want to share their line of thought or some code on how they went about solving this one? All right, but I'll walk us through it. So it says we want to find the difference, the absolute difference between the highest salary in the marketing department and the highest salary in the engineering department. So the first thing I guess we want to do is find those salaries. So to do that, I would like to select the max of salary from what? Well, we have the employee table and we have the ID department table. So that information is separated out. So we'd like to join these two tables so that for every employee, we know where what department they're in. And we're going to join on the department ID key from the employees table and the department table, the ID key from the department table. So we'll say from database employee. I'll give this an alias as E for employee, and we're going to join. We'll do an inner join on database department, and we'll give it an alias D. And we said we want to join on the employee department ID. Department ID is equal to the department.id. So now at this point we have, if we run our code, one error, department ID.
Salary, it should be salary.
Oh yeah, thanks. On e.department.
Oh, it should be join DB on, right? Oh, you have on.
Oh
on
my god!
twice,
Yeah,
on
yeah,
twice.
you're right. You're right. Yeah. My bad. All right. So now we have the max salary from some department, but we didn't specify. Unfortunately, the data set's so small that we actually don't see multiple salaries. But really, what we should be saying here is we want to say, well, where a department is equal to, let's get the engineering one first. All right, so this should give us the highest salary from the engineering department. And now what we want to do is we want to subtract that from the highest salary in the marketing department. It's going to be very similar code. We're just going to copy this over, minus, we're going to take this query, and we're just going to change engineering to marketing. And this is going to give us the highest salary in the marketing department. So now we have the engineering, we have the marketing. So now we have the difference. So the last thing we do is just say we want to select the absolute value of these two values. We're just all going to do is select the result of this subtraction. We run code. We get, well, let's say that's something useful as difference. We get 2,400, and if we run it, we should see that we get the answer correct. Did anyone have any different approach or want to add anything or anything? All right. Well, with that being said, then we'll go back to the. Approach. Oh, sorry. Oh, sure. Do you want to share your screen and show us your code?
Well, I can, but I would rather not to. But I just want to say I use CTEs.
Sure.
Like to have like this department in different CTEs, and then like at the end I just subtract and use the absolute value of them.
Okay, so you said like with engineering as whatever, and
Yep.
with mark as whatever.
Correct.
Select abs of eng minus mark, something like that.
Something like that. Yep.
Yeah. Okay. Yeah. So CTEs stand for. Hold up. What do we stand for?
Common table.
Yeah, so they're a way for you to sort of take out, sometimes these queries here can get pretty complicated. So they're a way for you to sort of factor out code and store it up in like a variable. So you can later reference it as many times as you want within the query. And it really helps for readability. All right. So if we go back to the notebook, we'll just move on to the second problem. If we just click on the link, it'll bring us on up. I will delete my code. So no. This one I thought was a little trickier. It's just a medium, but I feel like it's a little trickier than a medium. There are a few like edge cases or sort of things to think about for this problem. So we want to calculate each user's average session time. A session is defined as the time difference between a page load and a page exit. For simplicity, assume a user has only one session per day. And if there are multiple of the same events on that day, consider only the latest page load and earliest page exit. We want to output the user ID and their average session time. So again, I think we'll take about 10:27. I think we'll meet back at 10:42. So we'll give 15 minutes to this problem. For this problem, you really definitely want to look at the database that they give you to sort of figure out where, if you encounter any bugs, sort of where your lapse in logic might have been. With that, is there any questions? All right. So we'll meet back at 10:42, and anyone has any questions in the intermittent, just speak up.
What's going on over there? You guys having internet issues?
Uh, I don't think so. Are you?
No, I don't. Well, I don't think so. But for a little while there, it was just three of us in the Zoom room. But maybe
Oh,
it
I
is
put
on
you
my
guys.
end.
I put you into breakout rooms.
Yeah. Okay. Oh, okay. Okay. Never mind. So you were hopping breakout rooms. That's what was going on.
Yeah. Yeah.
Got it.
Yeah.
Got it.
Does everyone need more time, or do you think we're set? Or all right, I will take that as we're all set. Does anyone want to share their line of thought or solution, any sort of code for this problem? All right, well then we'll get started. So first thing I think I want to do is I want to first figure out every sequence of actions taken by every user. So the way I'm going to do that is I'm going to say I'm sharing my screen, right? Yeah. I want to select, we'll figure out what we want to select later. All from, what I want to do is I want to join this table with itself. So I want to do Facebook web log. And so let's just D1, and we'll join it. Join Facebook web log D2 on, well, we just want to look at what each user ID's successive action is. So we'll say D1.user ID is equal to D2.user ID. So now if we run this, because for every action, every other action that has the same user ID have been concatenated together. So now we want to sort of filter these out for the ones that we care about. So the next step is from here. Well, does anyone know what the next step is?
To play, start page and load page to filter out those.
Yeah. So you want to say where? Yeah, you want to say like D1.action is equal to page load, and where D2.action is equal to page exit. And does anyone know what the there's a third condition we need to consider for?
Date should be the same. Date section of the timestamp should be the same.
Not quite. Oh, sorry, the date section, sure, but the time sections are not going to be the same, right?
Yeah. So like there should be a same day, but might be a different time. So you need to extract date part of the timestamp, and it should be the same as the date section of the timestamp from the second D2.
It's not quite what I was thinking. What I had in mind was we want to find, so D2.action is the page exit. We know it's always going to happen. That should always happen after the page load. So what we want to filter out for is we only want to look at valid actions. So we only want to look at actions where the date of the time of the page exit is after the time of the page load. And the way I would say that is, and I want to say D2.timestamp is equal to D1.timestamp. Sorry, not equal. Greater than D1.timestamp.
But then you're gonna pick up all the other days too, right?
You should do this for every single day, right? It should be done once per day.
Yeah, later down, I'm going to group by day.
Oh, okay.
Okay.
Yeah. So right now, I'm just doing the filtering to get like the valid actions that can be done. Yeah, you're right. We will at some point have to do this by day. So we've joined and we've combined. So now the next thing I want to do is what do we want to select from here? Let's fill in what we want to select. We want D1.user ID. We want D1.timestamp. And we'll call this the D1.timestamp. And we'll call this start. This is the starting action. And we'll say we also want D2. timestamp as finish. We don't need d2.userid because we've already joined on them such that d1.userid is equal to d2.userid. All right, we run this code, make sure we get no errors. So now for every user ID, we have every start and finish. But now you're right, now we want to group by day. So the next thing I can do is I want to select everything. I want to select all guys from this table we just made. Right, I want to say, oh wait, sorry. I'm gonna, now that we have this table, what I want to do is I want to select the user ID. Well, we select whatever from this table we just made, right? But as we said before, oh, sorry. We want to group by day because we want to look at every day, the latest load and the earliest exit. So the first thing I know is we're going to have to group by, well, for every, what are we going to group by?
User and date.
Yeah. And the way I'm going to do that is I can just call this date function and just throw in start, and that's going to group by the date of start. So now we have, we know we want to group by this. So now we want to sort of throw in our aggregating functions for what we want to sort of aggregate from this data. So we group by user ID. So we need to select user ID, certainly. And then what is the problem state we want? For every user ID, we want to look at their latest start action. So what that means, we want to look at the max of the start. And similarly, they said we wanted to only consider the earliest finish action. So that means we want to look at the minimum of the finish. That makes sense to everyone? So we run this query. Uh-oh, what did I do wrong?
You might have to give it a temporary name, like from that parentheses.
Oh yeah, as some table. Okay, yeah, thank you. Thanks, Dan.
Yep, no worries.
Okay, so at this point, for every user ID, for every table, we have the earliest, the latest load time and the earliest exit time. So now from here, we see we have 2 actions for user 0 and 2 actions for user 1. Now from here, all we want the problem asks is take the average time duration. So now from here, all we want to do is we'll do another select. We'll select for every user ID we want the information, right? So we're going to select user ID, and then we want the average of the min minus the max from this whole table.
Where does it say it should be average? Oh, okay, user's average session. Okay, I see that. All right.
Yeah. So I want to select everything from this table. I want to select the average of the min and the max. Ooh, just tab this to make it a little easier to read. And all we're going to do is just group by, we want the information for every user ID. So I'll group by user ID. And hopefully done everything correctly. Once I run this code, must have an alias. Another thing is this alias thing. We'll just give it an alias called table2. We run, and now we have for user ID, the average time was 1883 seconds. For user ID 1, it was 35. And hopefully if we click this solution, we'll be able to see that we've actually solved the problem correctly. Just a little note over here, this is probably not so pleasant to look at. It's a little weird to look at, like, actually I'm a little surprised this even works. Because over here, I didn't rename these columns as anything. So what PostgreSQL is, it names the column off of the aggregating function. So really just for a little bit more cleanliness, we should really rename these as like, max, as min, and then just sort of say average of min minus max. I think it's just a little bit nicer to look at. It's a little weird to take the average of what essentially functions in SQL. When you run the code, it should be the same thing. Yeah. So are there any questions about this problem? Anyone have any ulterior line of thought?
Can you hear me?
Yeah.
Can I share my screen?
Yeah, sure. Let me just stop sharing this. Stop it sharing. All right. Yeah, welcome to share your screen.
All right. Can you see it?
Yes.
All right. So this is what I did. So my first goal is I'm trying to create one table which has a user and a date and a start time and like the load time and an exit time per day per user. All right. So here I am picking the load, I'm picking the load and I am joining it. It's kind of like the way you did, but I'm joining again to the
I see. Instead of like explicitly filtering, sort of like how I did, you're just like filtering out and then joining.
Yeah, and then here I'm saying, hey, go and just try to just match them user by user and also date by date. All right.
Yeah.
This is a part, I think it throws an error. I don't know exactly what.
So you said you have end data. You want to say date. Yeah. Is it Sql going to throw an error?
You see. Okay.
Column pl.timestamp does not exist. Line 10. Do you mind scrolling up a bit?
The problem of it is that you rename your timestamp already. It should be pl.l stamp equal to.
Oh yeah, you're right.
Yeah.
Yep. PL.
Yeah.
Yep.
Good catch.
I already changed that. And
you cannot name that. It's case sensitive, so it have to be lowercase.
All right. Thank you.
Yes, sir.
Possibly
Did you rename user ID as well? No.
You have to do p1.username.
Yep. It should be PL, and then this should be PE.
You have to put PL or PE for a username as well.
Thank you. All right. So I don't know what is happening here, but
Go up.
I think we're gonna continue on this session.
that's
we're
fine.
gonna go on to the next problem, but if you want, at the end of the session we can sort of look back at your code and try to figure out exactly.
No worries. Yeah.
The problem of that is
Okay.
your subtraction is backward.
Okay. All right.
Yeah, swap those.
Okay. Well, we're gonna get back to that.
All right.
But yeah, we can talk to you at the end and make sure everything's looking nice. All right. So we got our final and last SQL question today. We'll just go back to the notebook. We click on problem 3. Let me delete all this nonsense so you don't gotta go anywhere. All right, so we want to look at the cumulative sum of energy consumption. So questions from Facebook or Meta allegedly. So what we want to do is calculate the running total, the cumulative sum, energy consumption of the Facebook data centers in all 3 continents by date. We want to output the date, the running total energy consumption, and running total percentage rounded to the nearest whole number. So we're given three 3 data sets. We have one from the EU, North America, and Asia, or Europe, North America, and Asia. We want to figure out what it says, the running total of energy and the percentage rounded to the nearest whole number. So I think we'll do the same thing. We'll give you about 15 minutes for this one. So we'll sort of meet back at 11:15, and I'll be running around the breakout rooms if you guys have any questions.
I have a question before we start.
Sure.
For the percentage consumption, should that start at 100% or end at 100%? So it's like a percent cumulative sum percentage over the consumption that it's seen before, or is it?
And running percentage running rounded.
I just asked because I can't see the solution.
Can you guys not see the solution for this one, or can you not check your solution?
Yeah, this is a paid one.
Oh, my bad. Wait, let me make the breakout rooms and go into. I think it wants running, but let me make the breakout rooms and let me go into your breakout room and look at your code.
Okay. Sounds good.
All right, how's everyone feeling about that problem? Does anyone want to share a solution or a partial solution or sort of a line of thought?
So for the running total percentage, issue corresponds to the total energy consumption. I mean, running total energy consumption, right? Not as like, say, day one has certain percentage, then day two have certain percentage. It should be running one as well, right?
No, it should be, so day one has some certain percentage usage of the total energy consumption. So you have this whole data set of, you have a total energy consumption, and you want to say after day one, I've used up like 13% of the total energy consumption. And maybe after day two, it's like 27. After day three, it's 34. After whatever, and on the last day, it should be 100.
So say day one has 13%, day two has
Has what?
16%. Then for my column, it should be the one as 13. So say day one has 13 percentage for like usage, and day two have 16 percentage of usage. So for my running total percentage, the correct display should be 13 as low one, 29 as day two, right?
Yeah, I believe so. I didn't realize this problem was a paid one, so you guys can't actually check your solution, which is like very annoying.
Okay.
But let me share my screen with the actual percentage. I apologize about that. Let me just share my screen real quick. So the correct answer looks something like this, where day one or 1-1 is 13, 1-2 is 27, 3, 4, 5, 6, 7, you follow up at the end of the 100. And I'll run you through the query. We're running a little short on time. And since you guys weren't able to check your answers on this one, I feel like going through this is a little annoying. But for my solution, I ended up using a CTE. So my first step was, first of all, I want to combine all the data into one frame. So I named this CTE as all data. And I just select all from the Europe energy, the North American energy, and the Asia energy, and I union them all together. So union will just join them by row, join by row instead of by column. So you get just a longer table. And then I use union all because if you use union, then it's gonna omit duplicates. So I don't want to have, say on Facebook for the Europe energy, I don't want to have on, January 1st, use 1200 watts or whatever. And then I don't want to omit something in North America on January 1st that also produce 1200 watts or whatever the energy or power consumption is. I want to keep all that data. So that's why I use a union all. And then I also know at the end, I want a running total and a running percentage. So I'm certainly going to need to know the total consumption in the whole data set. So the second value here is total consumption. And what I do is I sum up the consumption from everything from all data. And that gives me a total consumption. All right. So now I'm going to start from the innermost query and work our way out. So the first thing I want to do is I want to, for every date, I want to figure out how much energy was used on that day. So what I do is I select date, I sum over consumption as total consumption for that date from select all from all data. So I want to sum over all the consumption from the CTE that I made. And I want to group by date, and then I order by date because I want my rows to be in order by date, so that when I look at the consecutive sums and percentages, they're all in order like this. And also you need to order them so that when later on the road we do this window function, the window is it's using an appropriate window, so the data is randomly ordered. So this inner query just gets us for every day the total consumption for that date. So now from this inner query, I want to select for every date. I want to select a date, and I want to use a window function. I want to sum over for every date. I want to sum up to that date the amount of energy used, and that's what this line here does. I sum total consumption for date over every date, it's going to give me a running total of the total used. Does that make sense to everyone? This is actually a little nuance of the over or window function. I didn't realize that calling a window function on a certain row, in this case, it's going to sum up all the dates, all the values specified from that row previous. So it's sort of built in a running total. That makes sense. So at this point, the table I have looks like this. Let me see if I can just exit this out. See, this runs. Hopefully, this runs. Your T3. I'll get rid of that. Okay. So this is what my table looks at this point. It's for the date 2020. I found that the running total is 1050 for 2020 January 2nd. Found that the running total is 2175. So now the only thing at this point is we need to calculate the percentage. So that's what this outermost query will do. I uncount all this. What this part does is I select for every date. I want to select the date. I want to select the running total, and then I want to add on the percentage, right? So the percentage is just I know the total consumption for the whole data set. I just need to take the running total of that date and divide it by the total consumption and multiply it by 100 to turn into a percentage. So that's what this does here. So we have the date, the running total, and then this line here will convert the running total into a percentage of running total. So once I run this whole thing, it should hopefully, as long as I didn't mess anything up, throw out all the information needed. Yeah. Are there any questions on this one? Oh, sorry. One last thing. This join down here, I'm joining the total consumption table with this table, and this one-on-one just means add a value onto every row. Are there any questions about this problem? I'm sorry, it was I didn't realize it was paid, so you couldn't actually run your code. But any questions about anything I did?
I don't think you need the first inner layer.
I'm sorry.
I don't think you need T. You can just do select dates for T.
Oh, you don't think I need this?
Yeah.
You don't think
you don't need this. You can delete like the inner query. Just say select the part you have from all data. It will do the same thing.
Oh, so just all data.
Yeah.
So just delete this. Delete
yep.
that.
And
but leave the alias, right?
You don't need the parentheses.
Oh, so this should work? You're saying?
Yeah, it should work. Should work as like this. It should do the same thing.
Oh, nice. Oh, very nice. Oh, I didn't know that. Yeah, I thought it was a little tedious to have to say, select all from this and select all, but I didn't realize that. Oh, thanks. So yeah, it makes it a little bit cleaner, even though this whole thing is like a jumbled mess.
You
but
probably can eliminate another layer.
Which layer?
Let me see. I think T2 is like unnecessary.
Unnecessary? You think I just get rid of that and that?
You can do all the calculation in like one layer. Yeah. No, you actually need that. Sorry.
You need the alias, right?
No, the part you said select all from T3, you don't actually need that. You can do the calculation there by yourself.
Oh, you know what? Yeah. So you get rid of that. I think I tried to delete that earlier, and I get some error.
You might have to fix your code up a bit.
Yeah. I'll get back to that. But if there's no other questions or comments on this code, I think we're going to actually move on to the Python part for the last 30 minutes. So if we all go back to the notebook, we're going to do a little bit of a warm up. We're going to do this recursion problem. So this one you may have seen actually in the bootcamp. We had a similar problem in one of our midterms where I wanted you to flatten the dictionary. I think this is a little like a step down. It's a little less involved in flattening a dictionary. Here we just want, given a list such as this, which could be nested with other lists, we want to write a function that flattens it, and that flattens it using recursion. So the idea is your function should take something like this. This takes this nested list and just returns the flattened list. And as a hint, I want to point you guys to the function isInstance. You Google it, you can figure out what it does, but it'll be useful for your code. So for this one, I think I'll give everyone, we'll look at 10-minute window. I'll check it on everyone. So at 11:40, we'll check back and discuss anyone's solutions.
You're on mute, Charles.
Welcome back, everyone. I was on mute. Does anyone have a solution, a partial solution, or a train of thought to this problem that they'd like to share? All right. If not, I'll share. I actually have two solutions. Do the same thing, just different style. So with recursion, I guess always the first thing to think about is the base case. So I just want to have some variable to hold my result, first of all, right? So now the base case is if we're iterating through a list of items and we hit a list, then we know that we need to flatten that list. But if we don't hit a list, we know that that element is atomic, and we don't need to call the recursive function on that element. So our base case is if not is instance L of list, we're going to return L. So what this is saying is if we hit an element that is not a list, meaning it's an atomic element, it's just some integer element, we want to return that thing as a list. Otherwise, what we do, so if this is not the case, then we move on. Let me get rid of this pass. And what we do is, well, now we know this thing is a list, right? So we want to say for every element in the list, I just want to take my result and I want to extend flatten of that element. And this is it, believe it or not. Recursive code is usually very, very dense. So once again, we have our base case. We want to say if whatever we're iterating over, so let's say our list is, I'll say L is just equal to 1, 2, 3, 4. Here, first these. So what happens when we get to the first element, we say, well, if it's not an instance, well, we just return that element, right? So we return 1 as a list and we extend it on to result. Then we go to the next side and we say, well, if this is not a list, then we keep on going. But since it is a list, we want to run flatten on this element. So this is the recursive part, is where now we get called flatten gets called onto this list element. And then it's going to iterate through every element inside this list and determine whether it's atomic or not. And if it's atomic, it returns it as a list. And if it's not atomic, then we call flatten on it again until we iterate through everything and hit atomic element there. So just to prove to you guys this thing actually works, let's just go, just go below. And I'll say flatten. I'll just take this list. Oh, did that work? We'll just do this. We'll just do 1, 2, 3, 4, 5, 6, 7. And what it's done is it's flattened the total list. So it's gone through, it's looked at the first element and the second element and seen that these guys are atomic. So it appends them to our result. Guess this third element, it sees that it is non-atomic. It's a list within lists. So it goes in and it looks at this first element and sees that it's still non-atomic. So now the function gets called, flatten gets called onto this non-atomic element. And now it sees in this first thing, there is an atomic element. So it appends it to our return value. And this thing gets appended to the return value. And now we're at the end of the list. So we return back. We look into this guy. We see it's non-atomic. We go in. We look at the first guy. We see it is atomic. So we append it. We go to the next guy. We see that it is atomic and append it. And we return back once we process everything here. And then we go on over here to the 7. And since it's atomic, we just append it to the list. I know it's like very confusing to look at recursive code, and honestly, half the time I write it, I don't believe it works. But are there any questions about this code? Okay. Well, if not, I'm actually I want to show a second way to do this. I'm just gonna copy this over because I don't want to type it out for the sake of time. Let's call this flatten 2. And this is really just a styling choice. They do the same thing, but it's just a styling choice. Some people you talk to might not like the fact that you've used a loop inside a recursive call. It's really, there's nothing wrong with it. It's just sort of a preference. So some people like it like this. So this flatten 2, it does the same thing as before. It says, well, first of all, if this is an instance of a list, then we look into it. And if we see if it's an empty list, then all we do is we return L. Else, this thing is not an instance of a list. It's an atomic element. We just say the left side, we flatten the left side, we take L of 0, which we know is an atomic element. And we say right side is flatten everything to the right of the left thing. And then this, these two calls get put together using this left.extend right. And then we return left. And then, like I said, this is actually swapped our base case down here. Some people like to write the base case at the bottom for whatever reason. I talked to a few people and they said they really prefer this style here, but I prefer this style here. So it's really just up to, it's like a styling preference. So are there any questions about this second flatten 2? Any comments? Anyone did it a different way? Anyone have any confusion on like recursion in general? Okay. Well, if not, we only have 12 minutes left in the session. So I think I want to just introduce this problem. And I guess we can just continue this for the next time I see you guys. But this problem called send more money, I think it's a classic problem. I've seen it in a few places. But the problem is you want to find a mapping from the letters in send more money to the digits 0 to 9, such that when you replace each letter with its corresponding digit, you satisfy this constraint such that send plus more equals money. Furthermore, S cannot be 0 and M cannot be 0 because I mean you have this digit padded with a 0. It's not really a digit, or sorry, it's not really a number if the number is padded with a 0 to the left. We can get started on this, and we can discuss the solution either at the end or we can do it at the next session if you guys want to like sort of think about it a bit more. But my hint for this is itertools is your friend. If you don't know what itertools is, it's a library built into Python that handles a lot of like iteration. It can, anything that you want to iterate over, it can iterate over, and anything you want to do over an iteration, it probably can do. So if you're ever interested in looking at permutations or combinations of some iterable object, probably itertools is probably your best friend. Are there any questions on the problem statement? All right. If not, for the 10 minutes I want to leave, I want you guys to fill out this function. It's just a send more money function, and it'll also return a dictionary of the mapping from the letters and send more money to the digits 0 to 9, such that this constraint is satisfied. The send plus more equals money. All right, and so for the last, I'll say 8 minutes, we'll just sort of think about the problem. I'll probably go over it next time I see you guys. I don't want to give you the solution before you've had adequate time to think about it. But if you guys want to think about it for about 5-7 minutes, we'll come back and sort of discuss what we thought. And next time I see you guys, we can go over the solution more in depth. And I'll put you guys into breakout rooms. All right, welcome back, everyone. We only have a few minutes left in this session, but I just wanted to see if you guys had any thoughts on the problem. Don't even have any code written down, but just what you guys can think of the problem. What would be your approach to this problem? All right. Well, I'm not going to share the code today. We'll go over the code next time. We'll probably just do this problem first thing for the next session. But for my approaches, the only way I saw was brute force. So I consider, all right, I'm going to generate every permutation of the numbers 0 to 9 I can. I'm going to, for every permutation, I'm going to map that to the letters and send more money. And then I'm just going to by brute force, given this mapping I have from the letters to the digits, I'm just going to create the number from the letter mapping and just add up whatever number send turns into, whatever number more turns into. I'm going to sum them and see if they turn out to be whatever number money turns out to be. So it's just a brute force approach. I generate every permutation of the digits, and I make a mapping from the letters to every permutation, to each permutation in the set of permutations I've generated, and then I just see if that mapping satisfies the constraints set out. So next time we'll go over the code for that. But until then, are there any questions about today's session or anything I can help anyone with before we end? All right. Well, there's no questions. I will see you guys next time, and we'll go over the solution to this problem, and we'll also talk about the probability question at the end that we didn't get to talk about. If you guys want to read that over and sort of mull it over before we talk about the solution next time. And there's nothing else from anyone. Take care. Have a great weekend.
Thank you. Bye.
See you, Charles.
Bye-bye.